What makes a hot air balloon rise? The answer lies in the groundbreaking work of 18th century scientist Jacques. Today, we will explore his life and the fundamental law that bear his name. Jacques was a true pioneer, a brilliant inventor and avid balloonist. He made the first manned hydrogen balloon flight in 1783. His passion for flight drove his research into gases. Interestingly, he never published his famous law himself. It was popularized by others who gave him full credit.
For definition, Jacques' law was founded in 1787 by Jacques. It states that for a given mass of an ideal gas at a constant pressure, the volume is directly proportional to its absolute temperature. Assuming in a closed system, the statement of Jacques' law is as follows: the volume of a given mass of a gas at constant pressure is directly proportional to its temperature. For theory, Jacques' law describes the relationship between the volume and temperature of a gas. For a fixed amount of a gas at a constant pressure, the volume of a gas is directly proportional to its absolute temperature. When you heat a gas, its molecules move faster and pull outward with more force, increasing the volume. When you cool it, the molecules slow down and the volume decreases. In simpler terms, heat it up and it expands, cool it down and it contracts.
This slide shows Charles' law, which states that the volume of a gas is directly proportional to its temperature when pressure is constant. The formula is V1 over T1 equal to V2 over T2. The T stands for the temperature in Kelvin, V stands for volume, and K stands for constant for fixed amount of gas and pressure.
One of the best examples of Charles' law in action is the hot air balloon, of which Jacques Charles himself specializes in. The main dynamics of the hot air balloon is the principle of buoyancy, which states that an object in a fluid experiences an upward force equal to the weight of the fluid it displaces. This means that a hot air balloon can only fly if the overall weight of the balloon is lighter than the displaced air around it. It achieves this by using Charles' law. By heating up air inside the balloon, it increases in volume and lowers the density without changes in pressure. The mechanism to make the balloon fly uses a compressed liquid propane burner below the balloon envelope to heat up the air inside it, expanding the balloon and lowering the density of the air. This creates a buoyant force against the heavier air outside, lifting the balloon until the air becomes too thin to provide enough force for a lift.
In conclusion, Jacques Charles transformed his passion for ballooning into a fundamental law of thermodynamics. His work reminds us that the volume of a gas is intimately tied to its temperature, a principle that continues to lift our spirits to this day.